You know how physicists are always trying to find that one theory to explain it all?
Right, the holy grail of physics.
Exactly. And string theory is like the ultimate contender, stepping into the ring with this wild idea,
Yeah, wild is a good way to put it.
saying that everything in the universe, and I mean everything, boils down to these tiny vibrating strings.
Like the strings on a cello or a guitar or something.
Yeah, exactly. Just like different vibrations on those strings create different notes, different vibrations of these fundamental strings would create all the particles and forces that we observe.
Okay, I'm starting to see the appeal.
And that's just the tip of the iceberg. Initially, string theory really captivated physicists because it hinted at possibly unifying those big players, gravity, and those three other fundamental forces, electromagnetism, strong and weak nuclear forces.
Which, let's be honest, have kind of felt like separate universes up until now.
Totally, each one with its own rule book, seemingly. But string theory comes along and says, hold on, what if there's a deeper connection here?
And figuring out that connection is about way more than just making our physics equations look neater, right?
Oh, absolutely. It's about cracking the code of reality itself. I mean, if string theory is right, it means that at the most fundamental level, everything is interconnected in ways we're just beginning to even imagine.
And let's not forget, this isn't just some random shot in the dark. We're talking about some serious physics heavyweights who've poured their lives into this.
This article about Brian Greene that we're diving into today, it really captures that sense of optimism, especially back in the 80s.
The 80s.
Yeah, it was like string theory's heyday. Scientists were buzzing, genuinely convinced that experimental proof was just around the corner.
Like by the 2020s, they were saying?
Exactly. Fast forward to now, and, well, things haven't quite panned out that way, have they?
Not quite, no. And this is where we hit the central roadblock with string theory. Testing it. It demands energy levels that are just way beyond anything we can achieve with our current tech.
I've heard it compared to trying to study the intricacies of a cell using a basic magnifying glass.
Yeah, you might get a vague outline, but all the really interesting stuff, the DNA, the organelles, they'd remain totally hidden.
And that's kind of where we're at with string theory, isn't it? We're catching these faint glimpses, these tantalizing hints, but the real nitty-gritty details are still beyond our reach. It's not just about building a slightly bigger, more powerful particle accelerator.
It's like we need a whole new level of technology that we haven't even dreamt up yet.
And even Brian Greene himself has acknowledged that the timeline for finding that smoking gun evidence, the kind they were hoping for by the 2020s, well, that timeline's come and gone.
And I think it's fair to say that this lack of direct experimental proof, it's led some physicists to start having second thoughts about the whole string theory shebang.
It's like waiting for a band to release a new album for years and they keep pushing back the date. You start to wonder if it'll ever actually drop.
Right, and you've got some folks who are still diehard fans, convinced it'll be their masterpiece when it finally arrives.
And others are like, you know what? I'm moving on. I've found some other great music in the meantime.
It's a valid point. If you can't test it, how can you ever be truly sure it's an accurate reflection of reality?
And that's the million-dollar question, isn't it? So we're still waiting on that definitive proof, that undeniable evidence to back up string theory.
Yeah, it's like we've got this beautifully crafted puzzle box, but we can't quite figure out how to open it.
And yet, even without prying it open, even without that direct experimental validation, string theory has been surprisingly fruitful.
Oh, absolutely. It's like we set out to invent a new kind of telescope and stumbled upon a revolutionary new way to build bridges.
Okay, I like that analogy. Tell me more.
So one of the most striking outcomes of string theory has been something called the ADAS-CFT correspondence.
Yeah, I'll admit, that sounds a little intimidating. Are we about to go full-on theoretical physics jargon here?
Well, it does get pretty complex, but at its core, the ADAS-CFT correspondence basically links string theory to a very well-established area of physics, quantum field theory.
Right, and remind me that is.
So quantum field theory is kind of the bedrock of how we understand particles and forces at the subatomic level.
Okay, so not some obscure fringe area of physics, then.
Not at all. Quantum field theory has been tested and confirmed over and over again. It's given rise to some of the most precise predictions in all of science.
Like what kind of predictions?
Well, take the magnetic moment of an electron, for example.
Okay.
Scientists have been able to calculate and measure that property to, like, 12 decimal places.
Yeah.
It's mind-bogglingly precise.
Wow, and this is all thanks to quantum field theory.
Exactly. And what's really wild is that the ADAS-CFT correspondence suggests there's this deep connection between string theory and this incredibly successful area of physics.
So it's like finding a secret passageway that connects two seemingly separate castles.
Precisely. It's this unexpected link that's opening up whole new avenues of research.
Okay, so instead of that direct flight we were talking about earlier, it's more like we're taking a scenic detour.
And who knows what amazing discoveries we'll make along the way, right?
This AD-CFT connection sounds like it's shaken things up in the world of physics.
It definitely has. It's giving physicists new tools to study things that were once considered completely untouchable, like black holes.
Black holes, really?
Yeah, and even the very early universe. Things that our existing theories could barely scratch the surface of are now becoming accessible thanks to string theory and this crazy AD-CFT connection.
So even if string theory doesn't end up being the be-all and end-all theory of everything,
It's still pushing the limits of our knowledge in some really profound ways.
it's like that saying, the journey is just as important as the destination.
Right.
Except in this case, both the journey and the potential destination are just absolutely mind-blowing. So where does that leave us then with this incredibly compelling theory, right? We talked about it, this theory that could potentially explain, I don't know, everything, the whole universe.
It's a bit of a head scratcher, isn't it?
Yeah, it really is. Because on the one hand, you've got this really elegant theory, really elegant, and it seems like it could be the answer, but then on the other hand, it's proving so difficult to actually test directly.
It's almost like we've stumbled upon this incredible treasure map, right?
Mm-hmm.
But we're missing a couple of key pages, or maybe the map's in a language we don't quite fully understand yet.
And that's what makes this whole thing so exciting and frustrating all at the same time, I think.
It really is this weird balance, isn't it? And it gets to the heart of why there's still so much debate about string theory.
Yeah, is this really it?
Is it the theory of everything? The big one?
Finally.
Or are we way off? Is this just this really elegant mathematical detour that's kind of leading us in circles?
It's tough to say for sure at this point, right?
It really is.
Yeah.
But here's the thing that I always come back to. Even if, and maybe this is a big if, even if string theory, at least in its current form, even if it doesn't end up being that final theory we've been searching for,
Let's say it's not.
it's undeniable that it's pushed the boundaries of physics in ways that we probably couldn't have even imagined a few decades ago.
And that's something worth celebrating, right?
Absolutely.
It's kind of like what they say, it's not about the destination, it's about the journey.
There you go.
Except, in this case, both the journey and the destination have the potential to completely blow our minds. It's pretty remarkable when you think about it.
Yeah. And you know what I find really fascinating about this whole endeavor?
What's that?
It reminds me a lot of other big scientific revolutions throughout history. I mean, think about Galileo, right?
Yeah.
Fighting tooth and nail to convince everyone that the sun was at the center of the solar system, not the Earth.
And everyone thought he was nuts.
Oh, totally. Or Darwin and his theory of evolution completely shaking things up, challenging the long-held belief that species were fixed and unchanging.
Right, that those were radical, revolutionary ideas back then.
Absolutely, they were. But they completely transformed our understanding of, well, everything.
Yeah.
The universe, our place in it,
Yeah.
everything.
And that's what I think is so exciting about string theory, you know? It's forcing us to confront some of the biggest, most fundamental questions about the cosmos. We're talking about the nature of space and time, the origin of the universe, and really the very essence of reality.
We're talking about the fundamental building blocks of what everything is made of.
Exactly. It's like we're standing on the very edge of the unknown, right?
Yeah.
Peering into this vast cosmic abyss. And even if we don't have all the answers right now, even if we never fully figure out this whole string theory puzzle, the very act of asking these questions, of daring to imagine these possibilities, that's what makes it so captivating.
Couldn't have said it better myself.
And on that note, here's something I want you to think about. Something for everyone listening to ponder. If you had the chance, if you had the opportunity to design the ultimate experiment, the one experiment that could definitively prove or disprove string theory once and for all, what would it look like? What secrets of the universe would you be trying to unlock? Keep those brainwaves buzzing, and until next time, happy diving into the mysteries of the cosmos.